So like you just read, there really are only two types of log equations that you will see. There's lots of variations on these two types, but the way you solve them is the same. So you could have an equation that has a log with the same base in every single term. So you can see in this first one we got log base 2, log base 2, log base 2, log base 2. The other type of equation that you may see is where there is not a log with the same base in every term. So in this one we have log base 8, and then we just have it equal to 1. So these are the two types. If you have a log base 2 in every term, you can start thinking, well, it will divide out. So it really does kind of cancel out of every term. You just have to be careful that you take your logs and combine them to a single log like we've been working with before you cancel them off, because it is very common for people to just want to drop these off and say, oh, I have 5 plus x plus 2 equal to 2 times 10, and that is not correct. So you have to join them using your log properties. We have the addition of 3 logs. So I'm going to go ahead and write log base 2. We have 5 times x times 2. So 5 times 2 is 10 times x is x. So we have log base 2 of 10x on the left side. That's just combining those into a single log. On the right side, you've got a power property going on. So we're going to write that as log base 2 of 10 squared, or I'm going to go ahead and write 100. At this point, if you are comfortable and you are good and you know to take the addition of logs and join it with multiplication, you could go ahead and not even write the log base 2. I just wrote it down so that we know we are good to go. So those can divide out. You can think of it that way. They don't really divide out, but they do get rid of each other. And on the left side we have 10x equal to 100. Now we've got a simple linear divide by 10. X is equal to 10. Final answer. Second problem. Just be careful that you don't go through and think, oh, my log base 8s are going to cancel out and we're going to have 2 times 4x squared equal to 1. That's not true. We're going to join them together. So log base 8, we have 2 times 4x squared, so that's 8x squared. And notice it's not in parentheses. It's just 8 times x squared equal to 1. Now we are trying to get to my final answer. We've got it written in log form. We can't do change of base to solve it, so that means convert to your opposite form. So in this case, exponential. Base is 8 to the first power equal to 8x squared. Very simple way to solve it. Divide by 8. We get 1 equal to x squared. Take the square root. Plus or minus 1 equals x. Just go back and double check, because you could never have a negative value here. So if we plug in a positive 1 and square it, we're going to get 4. If I plug in a negative 1 and square it, I'm also going to get 4. For instance, if you had log base 8, let's just put a negative 4, you've got to stop and think, what is this actually representing? This is saying a base of 8 to some power is going to give me a negative 4. Well, if I plug in a positive x, I'm going to get a positive value out. If I plug in a 0 for x, I'm going to get 1 out. If I plug in a negative, let's just say I do 8 to the negative first power, I'm going to end up with a fraction. It is not negative. So there is nothing that will ever make that possible. And it does happen a lot. You're going to get numbers that when you go back and check, you end up with a negative value here. That means that is not one of your final answers.